Hi, you guys. We are looking at waves, and you've already learned kind of what is a wave and some of the types of waves, which are highlighted here. We got mechanical and electromagnetic waves. We talked about what waves transfer energy, and some of the other kinds of mechanical waves as well. And then um, we have to get into today a little bit about what kinds or what are the properties of waves. And who knows how it's going to go with my COVID brain. But here we go. Let's make it happen. This is a pretty good picture of the different words that are associated with waves. I'm going to define each of them in a second, but you can see we've got the wavelength there, the crest, and then this is a different representation of wavelength, and the amplitude is how tall the wave is. And we're going to define all those things right here at the next part of the notes. And I'm just going to unhighlight them and talk about them quickly. And then there's going to be some math we do because we're also going to talk a little bit about the um, calculations and equations that go along with waves. See, it's already happening. All right, so the crest of the wave is the highest point of a transverse wave. A transverse wave is this one right here. Okay, a kind of a classic wave shape. Oopsies. And please pause if you need to fill in some of these things on your own note guide. The trow is the lowest point of the transverse wave, and the amplitude is how far away those points are from the middle. So the maximum distance of the particles of a wave vibrate from their rest position is just a fancy way of saying how tall is the wave. Okay, you can measure amplitude there where it's highlighted, or you can also measure it right here. Again, it's just the distance from the middle to the highest point, or from the middle to the lowest point. And it's the same on both sides, and that's called the amplitude. And if it's a spring, which would be a longitudinal wave, this wave is a transverse wave. A longitudinal wave is a spring. Instead of having crests and troughs, they have areas that are crowded and areas that are not crowded. You can see them very clearly here. The compression is the areas that are crowded, right here, and the rarefaction are the areas that are not as crowded. And that corresponds to the crests and troughs of a regular transverse wave. Oopsies. Oh, nothing to put in there. I'm going to skip that part where it says amplitude of a longitudinal wave. Okay, so now you know some of the parts of the waves. Let's talk about how we measure some things with waves. And then we're going to do some of the triangle stuff on the next page, and that would be doing some of the math. So you need a calculator or access. You can use your iPad if you want for some of the calculations on them. The wavelength is the distance from one point on the wave to the identical point on the next wave. So the wavelength measures the distance between two equivalent parts of a wave. Some waves are like waves in the ocean, very easy to measure the wavelength. Some waves are very, very small, like waves of light, a lot harder to measure the wavelengths. But we represent that with the Greek letter lambda, as you can see there. It's kind of like an upside down Y. This is the Greek letter lambda, and you'll be drawing it a lot, so kind of get used to seeing it. The period of the wave is the time it takes for the wave to pass through something. So if you're on a boat or in the ocean, the period is the time it takes for one complete cycle of the wave to happen. So if you are like bobbing up and then down in the ocean, the period is how long that takes between for each wave for that to happen. And period is represented with a capital T. Excuse me. Frequency of the wave is how many waves pass by in 1 second. We call that the frequency. So sometimes it's a very small amount of waves. Sometimes it's a very large amount of waves if the period is very, very small. So the frequency is number of cycles per unit time. And we measure frequency in hertz. When it comes to compression waves, or waves that you can hear, longitudinal waves, those are, that's the pitch of the wave. So your voice has a certain frequency, or a note on a guitar has a certain frequency. And that's just how many cycles happen in 1 second of that time. And you can see the equation there for frequency is equal to 1 over period. Another way of saying that is right there. Frequency is 1 over t. If we drew a triangle for it, it would look like this. Frequency equals the number 1 over t. Okay. And we're going to skip to the bottom here and then learn the other equation. We're going to show you some examples of them. And the other equations for speed, okay? Since speed is distance over time, if you convert that to wave talk, then really the important one is right here, that velocity or speed of a wave equals wavelength times frequency. Again, remember the upside down y is the wavelength, okay? So wavelength times frequency is the way that you would do speed. And looks like this. Velocity equals wavelength times frequency. There's your triangle for them. Now pause it here because this is where we're going to need a calculator. We're going to take a look at some of the other, some equations and some calculations with those wave problems. So I'm going to switch to the other part of the notes, which are somewhere over here. And let me get rid of all this so you can read it. And we'll just do a couple. So it's really important that you have the access to this so you can be able to do some of these problems and just practice them a little bit before I give you an assignment on them tomorrow. So, and this is already posted on Schoology, so please download it on the weekly document. The equation for wave speed is velocity. Velocity equals frequency times wavelength, or wavelength times frequency. Remember the triangle was velocity equals frequency times, sorry, it's wavelength times frequency, okay? So if you wanted to use that and, like, for example, find the frequency of a wave, or sorry, the speed of the wave in this problem, it says the frequency of a wave is 440, and we want to know the speed if the wavelength is 3.2 meters, so there is your wavelength. And so I'm trying to find velocity. So velocity right there, which means I'm going to do frequency times wavelength. So I'm simply going to take, say, velocity equals to frequency times wavelength, and the frequency is 440 hertz, and the wavelength is 3.2 meters. And if you take 440 times 3.2, you'll end up with 1408 meters per second for your label. Easy enough to do for those, because we've seen problems like that before, a lot of them actually. Okay, take a look at number 3. It says the wavelength of a wave is 0.5 meters, moving at 15 meters per second. What's the frequency of this wave? So if you want to find frequency of a wave, you're going to be doing this one, frequency, and you can see that frequency equals velocity over wavelength. Frequency equals velocity over the wavelength. So we're just going to plug those numbers in. The velocity of this wave is 15 meters per second, and the wavelength is 0.5 meters. And 15 divided by 0.5 is equal to 30. And you would say for frequency 30, the label for frequency is hertz. So frequency is hertz, wavelength equals meters, and the velocity is meters per second. Those are the labels that would go on each of those things. Hertz, why don't you work? Oh, there you go. Hertz, meter per second, and meters. For frequency and period, frequency equals 1 over period. The triangle looks like this. Frequency equals the number 1 over period. So if you're looking for frequency, oopsie, just go away. And if you're given that information, pretty straightforward to find these things. Again, just not a triangle problem. You've seen 1,000 of them this year, right? It takes a wave 0.75 seconds to complete one cycle. That's its frequency. That's its period. What is the frequency of this wave? So frequency is 1 over period. So frequency equals 1 over period. Again, period is going to be in seconds. T equals seconds. So plug the numbers in. 1 divided by 0.75. If you take 1 divided by 0.75, you will get 1.33. And the label for frequency, in case you forgot, we wrote it up here. Frequency is going to be hertz. Okay, you want to solve for period in this next problem. If given the frequency, what's the period? If I want to solve for period, then I'm going to do 1 over frequency. So I take period equals 1 over frequency. The 1 over 250 is going to be a much smaller number. Oh no. Okay, there we go. 1 divided by 250 is equal to 0.004. And the label for period is, right here, seconds for your label. That's how long it takes one wave to pass. And then just some review. It's important to know some of these definitions. Make sure that you're all over them. A sound wave is a mechanical wave, which means it needs a, think about them before I write it down. What means it needs a medium. If I measure the period, I'm measuring the time per cycle. Measure the frequency, I'm measuring the number of waves per second. Waves happen per second. So, good review of some of the math, or now you've learned some of that and seen some of the examples. Next time you are together, you'll have a worksheet to practice some of these, but that is a rundown of the two most important equations for the waves unit, which would be for velocity and for frequency. This has been super fun. Everyone take care. Okay, bye.